Device characterization is really interesting in that it's something that's discussed a lot tangentially in a lot of other courses and so forth. But here, you get to learn about it specifically as it pertains to specific devices and how it can affect your analysis if you're doing any kind of network analysis or if you're doing any kind of characterization of specific targets and devices, right? So that's one of the things that you get to apply specifically that you don't necessarily get anywhere else. So I'm going to give you a quick run through. We only have a limited amount of time, so I apologize if it's too fast. But the good news is that all of this is available up online. So the website up there on the left, Packet Hunters, I put all my classes there. So if you ever want to go back or anything, you can just check right there. All right, so basically to give you some quick objectives, this is something that we go through with a lot of classes. The main goal out of this, if you read through all these, and we could go through them one by one, but time permitting, we're going to breeze through. We're going to take what, in my line of work, I've had a few of my management individuals say, read the signals and read the bones, right? You're going to get a lot of packets and construct them in a way that will give you more of a picture. The idea is not necessarily taking a needle out of a haystack, but finding all the different needles in the haystack and then putting them back in the sewing kit in the correct order, which is kind of exciting if you know how to find the needles and you have a magnet, right? So that's kind of what we're going to give you here, a methodology of how to do that, how to pull all these things together, identify a specific device that is emitting packets on the network and characterize it as such. All right, so today, now everything generates packets. Everything that comes along has a packet attached to it in the Internet of Things. I'll give you an example. My house alone, the door talks to the thermostat talks to the Internet talks to, now it's talking to Google servers, so that's a little frightening, but everything's interconnected and everything has packets. And it's not just my door anymore, it's the lights. Even my light bulbs are now talking to each other and extending the range of that network. That's something that you want to keep in mind specifically when we're talking about Wi-Fi packets. All right? Every device now has a network interface controller, a NIC card, right? Everything has a MAC address. Everything has a specific device address that is attached to them that is unique. And when we talk about it, we have either wired or wireless. Both of them have these unique identifiers. These are key to remember when you're going through data. So, for those who aren't aware, NICs are identified by their MAC address. This is the unique value that's associated to a network adapter. Specifically, it's cut in half. You will have the OUI, which is on the next slide, all right, which is an ID, the organizationally unique identifier, which is specific to the manufacturer. All organizations that make these devices, all companies that make these devices have their own OUIs that are given to them that they have to put on for serial number reasons and tracking reasons and so forth. The second half is their own part of the actual MAC address that they can use for their own purposes. A lot of times you'll see this with devices. Specifically, the corporation will have some kind of alphanumeric code, or they'll have a one-up kind of numerology attached to them, where an example is if you buy a bunch of routers, specifically in bulk, straight from the producer, you can get something like AABBC1, AABBC2. And it's their way of not just keeping inventory, but also tracking specific devices. Everyone follow so far? Yep. Great. All right, real MAC address examples. If you go online and you actually want to see these examples, they're on the website. I encourage you to download the packets, and you can take a look after the fact. Here we have 3085A9. This is specific to ASUS Tech. It's been specifically assigned to them. And on the back end, we have 938DDB. This is their way of keeping track of what specific ASUS device ASUS has put out. All right? Then we have 544249, which is the Sony Corporation. In this instance, it is a Blu-ray player. And then B7769B, which again is an example of Sony keeping track of their own devices. And if at any point I'm going too fast, please just give me a signal and I'll slow down. So how did we know this? It's not magic. It's the internet, right? We took this information, we plugged it into one of many sites out there after we have the MAC address, which an example Ben will show you as we progress, right? And we put it into some of these sites, all right? And what it does is it gives you the information, specifically breaking out the OUI and telling you who made this device. Really easy. Anyone can do it, and that's incredibly frightening. All right, searching for the MAC address. So then the question comes along, how do we do this? Well, thanks to the universally available and completely free tool Wireshark, we can take packets that we've collected, throw them into Wireshark, and start running a series of filters. What do these filters do? They give you the Ethernet address, eth.addr equals, and you put in the MAC address. They tell you the Ethernet source. You put in the MAC address with eth source, eth destination, and the MAC address as well. What this will then do is filter through all the packets and identify only the packets that have the MAC address that you're interested in, whether it's you only want to see where that device is the source or that device is the destination. Same goes, not just with Ethernet, but wireless. WLAN address, WLAN source, WLAN destination. All right, progressing. So all of this is great, right? Everyone likes this idea of identifying devices. The problem is that these devices are not easily identifiable unless you're right next to them and collecting packets there. What is? The IP address. So that we need to cross that bridge and understand how the IP address and the MAC address are related. While understanding that the MAC address of a device is helpful, the more universal designator relies on the OSI Layer 3, all right? The OSI model Layer 3. Specifically, as you move up, for those of you familiar with the OSI model, you'll notice that Layer 3 is where the IP address lives. And using that IP address, we have a greater chance of success of being able to identify that device when we're not necessarily standing right next to it. How do we do it? We use my favorite filter, ARP. Why? Because it is the address resolution protocol. When you're just stuck at Layer 3 and want to get to Layer 2, or stuck at Layer 2 and you want to get to Layer 3, you can almost always rely on ARP. Specifically, because if you type in the filter, just ARP, you're automatically getting information that pertains to both Layer 2 and Layer 3. It literally will say, the address of this is at this, giving you key information for trying to paint this bigger picture of what device may be on your network. Here's an example, just in case, to reinforce. All right, I have pretty much the same filter we just spoke about. Ethernet.addr equals, so the Ethernet address equals this MAC address, and ARP. What do we have? A bunch of ARP packets, one of which says 192.168.2.125 is at this MAC address. So we have two very key bits of information that we can then use to start filling out a characterization of this device, understanding what's on our network. So far, we know that there's a device made by ASUS, or ASUS, however you want to pronounce it, right? With this IP address and this MAC address. We're getting closer to understanding our network and what's on it. Hopefully, though, you already understand, as a side note, what's on your own network and there's no reason, I should mention, by the way, unless someone's given you permission to legally be doing this to anyone's network. So always get permission. Disclaimer. Legal disclaimer. Only do this to your own network where you give your own rights out to. All right. Is there a browser? So browsers are important. It's important to know if a device has a browser, right? Because that's going to give you a better idea of what might be on that network. I used to be able to say, routers don't have browsers, but that's not the case anymore. Certain devices, however, will not have browsers. My light bulbs still don't have browsers. Thank God. All right? Give it time, though, I'm sure. So is there a browser? I'll tell you, fridges, actually now fridges have browsers too, if you check CNET in the last few months. So, but my light switch won't. Something that you'll be talking about with Ben a little bit later, the all-important HTTP filter. All right. Identifying the type of browser is huge because if you can identify what type of browser is being used, you might be able to identify what kind of device. For example, if it's a full-fledged browser, it could be a desktop, it could be a laptop. But if it's a mobile page, it's more likely to be a tablet or a cell phone or some other type of mobile device. Sorry, also of import before I move on, we're going to use something called the user agent to identify this. It's pretty much straightforward. A simple line of text that identifies the browser and the operating system of the client to the web server. So similar to how identifying the MAC address told us who made the device, the user agent will identify what type of browser is being used. How do we find the user agent? Well, there's a filter for it, believe it or not. Similar to other filters we've had, we then add on, instead of ARP, we have ethernet.source, should be familiar, or .addr would also work, and down here I have an IP.addr for IP address, equals this, and http.request.method equals get, or http.user_agent. What this does is provide, again, a series of packets that will provide you with the user agent information, hopefully. This is also a good moment, though, for me to mention to you, user agents are not always truthful. It is very easy to pretend you're something you're not. Simply stating that you're a Firefox browser doesn't necessarily mean that you are a Firefox browser. And I'll give a quick example. When services like Hulu and Netflix first came online, you could only watch them through your computer. Doesn't mean everyone wanted to watch them on their web browser. So they would use the browsers that were on their televisions and use plugins to pretend that they were actually the correct browser on a laptop to get it to stream to their television, thus pretty much circumventing the security measure that the companies like Netflix and Hulu had put in to ensure that people could only watch these shows on a laptop or computer, or desktop, right? Desktop computer. That's why you can never, that's one of many reasons, why you can never 100% trust the information that's put in the user agent string. In this instance, when we pulled the user agent string, we found out that it is a Windows 7 computer, 64-bit, with a Firefox 12 browser. That's at least what it says it is. And again, this is information that you can find on the internet through search engines. Literally typing up user agent lookup will provide you a string and litany of web pages that will provide you this information. Misleading user agents. Specifically, how is it misleading? Well, a lot of people will automatically think, looking at this information, well, it's clearly probably a Firefox browser and so forth, because they see that Mozilla. That's not the case, though. In this instance, it was actually an IE one. In this instance, again, people can get misled with Mozilla. What is this actually? Well, you see your Apple WebKit back here. You see Chrome mentioned, Safari. There's a lot of different ways to think, hey, it could be this. That's why we encourage you always to use specifically these websites that will provide you the information. Ones like this, useragentstring.info, useragent.com. So putting in the information, let's take this example, all right? We're seeing the Chrome, we're seeing the Safari, we're seeing the Mozilla. What is this actually? It's a Windows 8.1 computer with Chrome 38.0.2.125.111. Filling out the chart, I'm starting to really get a better idea of what's on my network, all right? We have an IP address, we have the MAC address, we have the browser type, the operating system. We think based off that, it could be a desktop or laptop. Let's take it a step further. What does the device say that it is? Looking at the NetBIOS naming system, NBNS, we can identify, using this MAC address, taking a little bit more of a search and a look at things, that the device is actually advertising itself as being named Frank Desktop. Oh no, now everybody knows my MAC address. Look out. All the more reason to think it might be a desktop. Again, taking it another step further, I don't know why I blocked this out because my email is readily available to everyone. But taking a look at the user, we can start adding additional information such as Ethernet source, frame contains, the almighty frame contains, and adding whatever we want in there to see if anything in any of those packets has this snippet of information. In this instance, it pulls up my email address. All right, using the post filter. The almighty post filter can get things even more, depending on your perspective, a little more concerning or a little more interesting. Using the post filter, different from the get method. Previously, with the get request, we were requesting information. In this instance, we are posting information. And in those instances, that's where you'll get things such as not just usernames, but passwords, depending on the encryption level if it uses HTTP. Hopefully most things don't now, but it'll pull all that information for you. Finally, you can use resources like centralops.net to look up the IP address and see the whois information that's associated with it. And then once everything's done, you can pull it all together and take a look at your fully filled out characterization chart you've made for your device. Whereas when you started, all you knew was there's a bunch of packets and the internet. You now know what devices are on your network.